Hello and welcome back to Unit 2, Graph 2. In this tutorial, we will be solving the following exercise. Solve the simultaneous equations 3x minus y equal to 1 and 6x minus 2y equal to 2. For the first straight line, let's go ahead and extract three coordinates. When x is equal to 0, y is equal to minus 1. And that is our first coordinate. Now for the second one, the equation is going to be 3 into 1 minus y equal to 1. So 3 minus y equal to 1. So minus y is equal to 1 minus 3. So minus y is equal to minus 2. Divide both sides by minus 1. So y is equal to 2. And for the third point, 3 into 2 minus y is equal to 1. So 6 minus y is equal to 1. So minus y equal to 1 minus 6, minus y equal to minus 5, divide both sides of the equal by minus 1, so y is equal to 5. These are the three coordinates for the first straight line. Now for the second, when x is equal to 0, minus 2y is equal to 2, so divide both sides of the equal by minus 2, and y is equal to minus 1. Now when x is equal to 1, 6 minus 2y is equal to 2, so minus 2y is equal to 2 minus 6. Minus 2y is equal to minus 4. Divide both sides of the equal by minus 2, so y is equal to 2. Now for the last one, 6 into 2 minus 2y is equal to 2. So 12 minus 2y is equal to 2. And minus 2y is equal to 2 minus 12, since we're flipping the 12 to the other side. And minus 2y is equal to minus 10. Now divide both sides of the equal by minus 2, so y is equal to 5. After we have extracted the coordinates for both straight lines, let's go ahead and plot them. For the first one, point of abscissa 0 and point of ordinate minus 1. Second point, point of abscissa 1, point of ordinate 2. Third point, point of abscissa 2, point of ordinate 5. This is the straight line for the first equation. Now for the second, take a closer look, and you're going to find out that they have the same exact coordinates, 0, minus 1, 1, 2, and 2, 5. Which means that this straight line represents both straight lines, both equations. So basically, we can deduce that if the graphs are the same, there is an infinite number of solutions. Both equations have the same straight line representing them on the graph. So every point on this straight line is the solution. So there are infinite number of solutions.